Okay, good morning all of you dear students. How are you doing? How are studies going regarding your 10th board exams? Okay, so I welcome you all to another electrifying session of SISYA class. Okay, yesterday you must have watched the first session of math SISYA class. Okay, so now today I am here to present the first revision series of chemistry to all of you. Okay, fine. So now let me introduce myself Akash, okay, and I am the chemistry master teacher at SISYA class. So today I am here to present an important session that is very important regarding your 10th board exams. Okay, now as you all of you know that your 10th board exams are going to start on 17th of Feb. Okay, so you all must have started your preparations. Okay, so to add to that preparation, we have just announced that one-time revision series for all the subjects, that is physics, chemistry, biology and mathematics, for all you grade students. Okay, and this is for all the grades and all the boards. Okay, this is for CBSE students as well as state board students and ICSE students too. Okay, so that chapter, let me just introduce the chapter. You all must have seen the chapter here only, that what we'll be learning today. Okay, so we'll be learning the one short revision series of chemical reactions and equations. Okay, this chapter you all must have been learning from since ago. Okay, from last 3-4 years you must have learned this chapter in different grades. Okay, but for this year, for 10th grade, this chapter is very important. Why this is important, we'll be discussing today along with you all. Okay, I hope you all are ready for the electrifying session coming to you live. Okay, now if you have joined, please kindly keep your notebooks in your hand so that you can note down the important points, because in this video I'll be telling you, along with the concept of chemical reactions and equations, I'll also be telling you some very important PYQs, MCQs regarding the various concepts, and we will also be discussing the probable questions. Yeah, the probable questions that must be coming in your upcoming board exams. Okay, so this session is very important for all of you. Okay, so let's start the session. Okay, so let me just introduce the topic to all of you. Okay, just give me a second. Okay, so this is the mind map of the chapter that we'll be discussing today. Okay, so we'll be going through each and every topic of chemical reactions and equations one by one. Then we'll be solving the MCQs of each topic after completing that topic. And in the end, I have kept so many important MCQs and PYQs as well as important probable questions that we'll be solving today. Okay, so let's start the session. Okay, so as you can see here in the mind map, I'll just introduce the chapter a bit, then we'll start with topics. Okay, so in chemical reactions and equations, first we'll start with chemical reaction. What is a chemical change that you have already studied in grade 7? We'll just go a bit through it. Okay, then we'll be going through the detail of chemical equations. Why is it necessary to balance a chemical equation? Okay, that is very important. Balancing the topic is very important regarding your board exams. Okay, so we'll be discussing the balancing of chemical equations. Along with that, in chemical reactions, we'll define it. Okay, then we'll see the characteristics of a chemical reaction. How will you identify that whether a reaction is physical or chemical? Okay, so we'll be going through that. Okay, after that, after the characteristics, we'll be discussing the types of chemical reaction. Okay, in the types of chemical reaction, as you all must have been knowing already, but let me just introduce it, that there are many reactions such as combination, decomposition, displacement, double displacement and redox reaction. We'll be discussing it one by one. Along with it, we'll be solving some questions also. Okay, and then in the end, we'll be seeing the effects of oxidation and rancidity. That is your corrosion and rancidity part. Okay, we'll be seeing that. Then we'll be solving some PYQs. Okay, so we'll be doing it one by one. Okay, so are all of you ready for the session? Okay, I hope all are you excited and ready. So let's start it. Okay. Now, let me first just introduce it that with the basics. Okay, these you already have studied in your lower grades. Still, we must start it with the basics. Okay, so if you have any doubts or any glitch in that, then it will be clear. Okay, So I'm talking about identifying changes. Okay, when I say identifying changes, how will you identify that if a change is happening, whether that is a physical change or a chemical change? That is the most important thing. First, before studying the chemical reaction or balancing the chemical equations, we must know that what is a physical or a chemical change. How will you identify that? Okay, how will you distinguish that? Okay, so to distinguish that, we'll have some characteristics. Okay, but before that, what is a chemical reaction? Okay, what is basically a chemical reaction look like, or how will you define the chemical reaction? So we just observe that a chemical reaction occurs when your chemical bonds are broken and formed. Okay, when a bond is broken and a new bond is formed, okay, so a new compound is formed, then you say that a chemical reaction is happening and it results in the formation of new substance. That is very, very important. Okay, if a new substance is formed, okay, if a new substance is formed, then you can say that it is a chemical reaction. This is the must for a chemical reaction to happen. A new substance should be formed whose chemical composition, chemical properties must be different from that of the original component. Okay, then only we can say that a chemical reaction has occurred. Okay, now so I'm just trying to explain it with you an example. Okay, so how can we define it more precisely? That any process, okay, listen it carefully, huh, students? So any process in which one or more substance, okay, one or more substance, here you can see there is only one substance. Okay, and what is this substance called? This is called reactant. That takes part in a chemical reaction, that is called your reactant. Okay, so when one or more substance, there can be more than one. Okay, in this reaction there is only one reactant. Okay, so when one or more reactants react in the presence of heat, temperature, light, pressure, all these things that we will be discussing later, to form products, this new substance that is formed is called products. Now it can also be more than one or one also. Okay, so in this reaction there is only one reactant that is breaking down to form two products. Okay, as you can see here. But there are various types of reactions. In some reactions, two reactants react to form one product. In some reactions, one reactant break down to form two products. Okay, so there are various reactions. We will be discussing it one after the other. Okay, so for now, this was the basic that I just wanted to discuss it with you so that you just get an idea, an early idea of a chemical reaction if you are lagging somewhere. Okay, now moving forward. This is just an example for you to understand the chemical reaction in a much better way. Okay, so as you can see in the picture that is depicted here, that there are two reactants, there are two funnels in which two reactants are kept, A and B, and they are reacting to form AB. And what are these bubbles showing? These bubbles are showing that a gas is released in this reaction. Okay, so these bubbles are showing that a gas is released in this reaction. Okay, now what is this reaction like? Let's just go through the reaction. So here magnesium, which is denoted by Mg, it is reacting with oxygen, that is your O2. Okay, because it presents in the form of molecule. As you all know that gases are always present in the form of molecule. Okay, so magnesium reacts with oxygen. In book you generally found that oxygen is represented as air. Okay, so we can also say that magnesium is burnt in the presence of air, because any oxygen reaction is a combustion reaction. Okay, so combustion is going on here. So magnesium burns in the presence of air to form magnesium oxide. So what's your magnesium oxide? It's MgO. Okay, now is this reaction balanced? Is this reaction balanced? Now what do you mean by balancing? We'll see in the next slide. Okay, so now for now just remember that if two reactants react to form a product, or if one reactant is breaking down to form two or more products, okay, or vice versa, then these are all chemical reactions. So here you can see that the properties of magnesium and oxygen will be different. It will be different from that of your magnesium oxide. So this is your chemical reaction. Okay, now let's see the characteristics of reaction. That is very important to understand the chemical reaction in detail. Okay, so the characteristics of reaction, you can also say it as the evidence of reaction, that we are just finding the evidence then how a chemical reaction is occurring or whether it is occurring or not. Okay, so for that we have to see some characteristics in the product side. Okay, that whether any of this is changing or not. It can be more than one. Okay, or any of these characteristics is changing in the product side, then we can say that this is a chemical reaction that is happening. Okay, so what are the characteristics? So the characteristics are change in state. You know there are three states: solid, liquid and gas. Okay, or color. If there is a change in state, whether from solid to liquid, liquid to gas, or from gas to liquid and liquid to solid. Okay, or there is a change in color. Okay, then this is one point where you can say that it might be a chemical reaction. The another one is your evolution of a gas. Okay, if during the reaction some gas is evolved, as I've just shown you earlier that hydrogen gas or some gas is evolving in the last slide. Okay, so likewise, if a gas is evolving, now how will you identify that whether a gas is evolving or not? It can be through a change in color that we'll be discussing with examples. Okay, you all must have heard about carbon dioxide turns lime water milky. Okay, so there is a change in color that is identifying that a chemical reaction is happening, or either a gas will released. Okay, if there is a reaction of an acid, in every acid reactions mostly hydrogen gas is released. Okay, so through that you can identify that the reaction is happening. Okay, now another one is your change in temperature. Okay, so these two words you are very familiar with, exothermic and endothermic. Still, I'll just brief it down a bit for you. So exothermic reaction, what does it mean? Exothermic basically means release of heat. That means during a reaction, heat is released. That means the reaction is so vigorous, so reactive that they already react and it results in the formation of heat or release of heat. Then it will be exothermic. And second one is your endothermic reaction. What does endothermic mean? Endothermic means if the reaction absorbs some heat. Okay, so what does it mean? That without heat or without increasing the temperature, these reactions are not possible. Okay, so if the reactants are not that reactive, then you have to increase its temperature in order to carry out that reaction. Okay, so that is your endothermic reaction. Okay, we'll discuss it with examples as we move on further. Okay, and the last one is your formation of precipitate. This is also very important because this is a separate chemical reaction which we'll be studying in the coming slides. Okay, so if a precipitate is formed, what does a precipitate mean? It means an insoluble substance that is formed in the product side. If the product contains an insoluble substance or solution, okay, then it will be mostly solid only because it's insoluble, so that will be your precipitate. So if any of these is changing in the product side, okay, after a reaction, then you can identify it as a chemical reaction is occurring. Okay, these you have already studied in your lower grades. Still, I just revised it for you so that you can understand the chapter much better. Okay, so now moving on to the chapter. Now these are some common radicals that you have learned in your 9th grades. Okay, these are very important for balancing the chemical equation. As all of you know that for balancing a chemical equation, one thing is very, very important. What is important? That you must know the valency and the oxidation number of elements in ions. Okay, and to know the oxidation number, we must know the atomic number. Okay, so that periodic table is also very important. Okay, so I have just put it down some radicals for you and along with their valencies. Okay, that is very important for balancing the chemical equations. So just go through it once. That in hydroxide, as you can see, in hydroxide the valency is -1. Okay, for carbonate it is -2. For nitrate it's carbonate -2, hydroxide -1, nitrate it's -1, and for ammonium it's +1. Okay, so these are some important polyatomic ions. Now some more are there. For dichromate it's -2, for sulfate it's -2, for bicarbonate it's -1. If no number is written here, that means -1, and for acetate also it's -1. So For simple ions, you all are knowing its valencies and their oxidation numbers, but for some polyatomic ions, some of these I have put in here. Okay, for these polyatomic ions, you might not be remembering exactly what is the valency, okay, or what is the charge present in that ions. So for that I have just kept these few radicals along with their valencies here, so that when we will be balancing the chemical equations, you can just revise it bit from here. Okay, now let's start writing the chemical formula. So now I am just telling you that in a chemical, let's take an example of a chemical reaction. If this is a chemical reaction, A plus B gives C plus D. Okay, this is a chemical reaction. Here you can see there are two reactants and two products. Okay, so there are two reactants and two products. So which law do these chemical formula follow? Okay, so these chemical formula which we have just seen in the previous slides, these all ions, how do they come? How do their valencies be obtained? So all these follow the law of constant proportion. You have studied these two laws in class 9th. Okay, one is your law of conservation of mass and the another one is your law of constant or definite proportion. Okay, so the second law, that is your law of constant proportion, what does it state? It states that in any chemical compound, if you take any chemical compound, all the elements that are present in that chemical compound, their ratio will be fixed. And how does that ratio comes? That ratio comes by mass. Okay, so if you put their ratios in mass, it will be fixed. It doesn't depend upon the source from where we have taken those compounds. For example, if we take water from a pond, if we take a distilled water, if we take water from some another source or water vapor, everywhere the formula of water will be H2O only. Okay, so that is what this law states that. Okay, and that is what these chemical formulas are made up of. They follow the law of constant proportion. That's why their valencies are fixed, their formula is fixed, everything is fixed. Okay, now how do we write a chemical formula? This is just a revision, so it can be easier for you to balance a chemical equation. So if we have to write calcium chloride, I have also shown it through a figure. I'll just also write here. If you want to write the chemical formula of calcium chloride, just write calcium, the symbol of calcium here, and just write the symbol of chlorine here. Okay, now you must know the valencies of both these elements. So the valency of calcium is +2, whereas the valency of chlorine is -1. Now you interchange the valencies, you cross multiply it. So here comes Ca1Cl2. Okay, so this gives the formula of calcium chloride as CaCl2. Okay, now another one for you, calcium carbonate. This is calcium carbonate for you. Okay, so here you can see the calcium again has valency 2 and the carbonate also has valency 2. The positive and negative charges cancel each other, so we don't take that into account while writing the chemical formula, since it's a neutral compound. Okay, so these two cancel each other, and there comes the formula CaCO3. So these two are the examples that how chemical formulas are formed. Okay, now let's just balance the chemical equations. Okay, so this is the first main topic of this chapter, that is your balancing chemical equations. Okay, because one short question will come from this. Okay, whether it will be an MCQ or in a case-based question, okay, or an necessary reason, but one balancing question is must. Okay, so just concentrate here, all of you. Okay, so now balancing, just I have given an example that how do we balance or how do I balance in a much easier way, so that if any complex chemical reaction also comes, we can balance it in the similar way. Okay, so this is just an example, then we will be solving some chemical equations to balance. Okay, so here you can see there is a reaction of zinc with sulfuric acid, and that is giving us zinc sulfate, and hydrogen gas is released. Okay, so now in this reaction, in reactant side we have zinc and sulfuric acid, in products we are getting zinc sulfate and hydrogen. For balancing we don't need compounds, we just have to write the elements, because we balance the elements. Okay, because that is based on our law of conservation of mass. What does law of conservation of mass tells us? That the mass of all the atoms of elements present in the reactant side and the product side in a chemical reaction must be equal. Okay, so to equal, that's why we balance the chemical reaction. This is also a question that has already been there in your previous year exams, that why we need to balance a chemical reaction. So we need to balance a chemical reaction just to follow the law of conservation of mass. What does it tell us? It tells us that the total mass of reactants must be equal to the total mass of products. For making the masses equal, we have to balance the number of atoms present of each element in both sides. Okay, so now here you can see we can make a table like this for balancing. Okay, when earlier you will start balancing, now you can just make a table. After you get pro, after solving some questions, then it's not necessary to make the table, but initially it will be much convenient if you make that table. Okay, so like this, I have written the elements here. So what are elements present in this reaction? So there is Zn, that is your zinc. There is H, that is your hydrogen. There is S, that is your sulfur. And there is O, that is your oxygen. Okay, so we are writing the elements in the leftmost corner. Then we are making two more columns. One is for reactant and another is for product. And we'll likewise write the number of atoms present in the reactant of these elements and in the product. So zinc, as you can see, there is only one atom, so here one. Here also zinc, there is one atom, so one. Hydrogen, you can see there are two atoms in the reactant side, so we have written 2. In the product side, we have also 2 atoms, so we have written 2 here also. Now in sulfur, we can see there is only one atom in the reactant side, so we have written 1 here. In the product side also there is only one atom, so we have written 1 in the product side also. For oxygen, in the reactant side, we have kept 4, because there are 4 atoms, and here also in oxygen there are 4 atoms. So now in these reactions you can observe that all the elements are having same number of atoms on both the sides. So this is a balanced chemical reaction for you. I was just giving an example. Okay, then we will solve a unbalanced equation and we will try to balance it. Okay, in a much easier way. Okay, so this reaction is balanced. I hope you understood it, that how do a balanced reaction looks like and how to make a table. Okay, now we'll try it with an example. So these 3 things you have to keep in mind while balancing a chemical reaction or chemical equation. What are those things? First, you must make sure that the number of atoms of each element is equal on both sides, as you can see in this reaction, that the number of atoms are equal on both sides. Okay, now the second one is always start balancing with the compound or with the element, being more precise, always start with that element which has the maximum number of atoms. Okay, to start balancing we must do it step by step. So the first element must be the one which contains more number of atoms. Okay, one more thing I want to tell you here, that always balance, which I haven't written here, always balance oxygen and hydrogen in the last. These I have always applied while balancing equations and it has helped me a lot. That's why I am sharing this with you, that always balance oxygen and hydrogen in the last. Rest all other atoms you can balance it one by one. Okay, and in the end, sometimes, most of the times you will see that the hydrogen or the oxygen is already balanced while balancing other atoms. Okay, and last, that you can't alter the formula of compounds or elements while balancing. That means for water you have to use H2O only. You can't change the formula. For calcium oxide you will use CaO. Okay, so for each element or each compound you can't change their original formula. You can just increase the number of atoms here in order to balance the number of atoms, but you can't change the formula. Okay, now this is a reaction. Now we will balance this. Okay, so how we will balance this, you will see. So let's just now balance this reaction. Okay, so let's just now make a table. So here it is element, Now here you can write reactant in short and you can write product in short, because we have to make it quick also, because time management is also very, very important, especially in science. Along with solving correct questions, you also have to answer the questions in a proper time. If you will take more time for easy questions, then it will be difficult for you to solve the much lengthier ones. Okay, so you have to manage the time. Okay, and start managing time from now onwards. Even when you practice at your home, just try to solve the questions in a precise time. Okay, don't just solve questions idly without taking a time. Just fix a time for each question. If it's an MCQ or very short answer type questions, just take 1 to 2 minutes for that question. If it's a short answer question, take 3 to 4 minutes. For a long answer question, you can take 7 to 8 minutes, 10 minutes max. Okay. And for a case base also, you can take 8 to 10 minutes. Now, let's just write all the elements first. So there is hydrogen, there is iron, there is oxygen. So you can see there is iron, there is hydrogen, there is oxygen. So I have written all three of them. Then write the number of atoms present in the reactant and product side. So now let's first write in the reactant side. So the iron, the number of atoms is 1. For hydrogen, the number of atoms is 2. And for oxygen, the number of atoms is 1. Here, for iron, the number of atoms is 3. For oxygen, the number of atoms is 4. For hydrogen, the number of atoms is 2. So first you have to prepare this table, okay, in order to solve a chemical equation, in order to balance it. Okay, after preparing this table, you must quickly see that which is the main element here. So the main element, the main metal that is present here is iron. So we will first try to balance iron. Okay, I have always tried to start balancing from the main element or from the metallic element. Okay, just balance hydrogen and oxygen in the last. You will see how easy it becomes to balance a chemical equation. Okay, so now in order to balance the iron, now here in reactant there is 1 atom, in product there is 3, so we can multiply the reactant side by 3 so that it becomes equal. So we'll just put these number in front of iron on the reactant side. We can't put number in the subscript. Anything that we are multiplying, we'll multiply in the front only. Just remember that. Okay, some students multiply it in the subscript and they get it wrong because you are changing the formula. Because the formula of iron is Fe. Now you can't change it to Fe3. Okay, so we can put the number in front of any element. So I'm just putting 3 here. So now you can see the iron is balanced on both the sides. Now let's go to hydrogen. Okay, so here hydrogen is 2, oxygen is 2. So both sides the hydrogen is already balanced. Okay, so now let's move on to oxygen. Now when we move on to oxygen, we'll observe that in reactant side there is only 1 atom of oxygen. Okay, so in product there is 4, so we can multiply the reactant side by 4. So where is oxygen present here in reactant side? In this compound. So we'll put 4 in front, not in the subscript. Remember this, all of you, that we have to put this 4 in front. Okay, now when we are putting this 4 in front, what are we observing? That the oxygen is balanced now, but the hydrogen is also changing in the reactant side. Okay, now when we multiply the subscript with the number 4 to the 8, so the hydrogen becomes 8. So now when we balance one element, you will observe that some another element is also getting unbalanced. Then afterwards you have to balance that element also. Okay, remember that step. So now we'll balance the hydrogen part. So here it's 2. So now you multiply it by 4 to make it 8. So now hydrogen is present here in product side. So you multiply it by 4 by putting 4 here. Okay, so now observe this reaction. Now you can see there are 3 atoms of iron on both sides. There are 8 atoms of hydrogen on both sides. There are 4 atoms of oxygen on both sides. So now this reaction is your balanced. Okay, I hope this reaction is clear to all of you. Now in this class we will be solving many more such balancing chemical equations. Okay, to make it more clear for you. Okay, so now let's move forward. So now this is one more reaction to balance. Okay, so now let's see how we will balance this reaction. Now remember one more thing here. Whenever in any reaction gases are present, Now all of you know that gases can't exist as an atom because of their intermolecular properties. So they exist as molecules. So you just make sure that whenever you are writing a gas, you have to keep it as a molecule, not an atom. You can keep it metals and non-metals as atoms, but for gases you will have to keep it as molecules. Okay, so here we'll put hydrogen molecule and chlorine molecule. Okay, and they react to form, I'm just writing the chemical formula first. Okay, so it will give hydrogen chloride. So the formula of hydrogen chloride is HCl. Now initially you have to make the table. The table is not compulsory to make. Okay, I have just made the table to make it much more easier for you. So in initial phase you will make that tables, or for difficult chemical reactions. But for simple chemical reactions you can solve it directly. How? I'll just show you. Okay, so now this is a simple equation. Why simple? Because only two elements are there. Okay, and both have two atoms in them. Okay, so in order to balance them, can we just multiply 2 here? If we just multiply 2 here, then you can see the hydrogen atoms are 2 on the product side, the chlorine atoms are also 2, and the reactant side also both are 2. So this reaction is balanced now. Okay, so for easier reactions you can just directly put the number in front and you can solve it. You don't have to prepare a table. But for complex reactions or where 4 or 5 elements are there, it will be much more easy to prepare the table so that no mistakes will occur. Okay, now let's solve some MCQs regarding it. Okay, so now these already I have discussed this reaction with you. When magnesium ribbon burns in air, I have just told you that in chemistry air here means oxygen, that is your O2. Okay, so whenever you have to do a reaction with air, you will react with O2. Okay, so now magnesium ribbon is denoted by Mg. So now Mg is burning air, that means Mg plus O2. Then what will be formed? We have just seen that reaction before. So what will be formed? Magnesium oxide will be formed. Anything that burns in air or reacts with oxygen always forms oxides. Okay, remember that. Now, is this balanced? No. Then how will we balance it? So to here, since magnesium is already balanced, now you have to balance oxygen only. So to balance oxygen in reactant there are 2 atoms. In product there is only 1. So you put 2 here. Now the oxygen is balanced, but the magnesium goes unbalanced. So now put 2 in front of magnesium in reactant side to balance this reaction. Now this is a balanced reaction. So which of the following occurs? So now I am just giving you a very important information regarding magnesium oxide. This is also a question, a PYQ from last year's question paper, that whenever magnesium burns in air, it forms a white powdered substance. White powdered substance. And it gives a dazzling flame. This reaction gives a dazzling flame. So these 2 things are very important regarding this reaction. Okay, so it gives a dazzling flame. Also it forms a white powdered substance. Okay, and these white powdered substance is your magnesium oxide. Remember these 2 points. This is a very important question for your upcoming exams. Okay, so here in this question, what will be the answer? It will be your white powder formation. Okay, clear? Next. Okay, so this is your next question. You have to write the chemical formula of ammonium dichromate. Okay, now let's just see how the formula comes. Now ammonium, you must know the formula of radical first. That's why I have discussed that radical sheet with you. Okay, so you can just remember these radicals first. So ammonium is denoted by NH4 and dichromate is denoted by Cr2O7. These you have to remember. Okay, you have to learn this. Okay, this was already in your 9th grade in Atoms and Molecules chapter. Now you must remember the valencies of this. So I have already shown you the valency of ammonium is +1. The valency of dichromate is -2. Okay, now if you cross multiply it, it becomes NH4 twice Cr2O7. Okay, so what will be our answer? Our answer will be option A. Now remember one more thing, whenever there are more than one atom, there are more than one element present in a compound and you have to put a number in it, you have to put this bracket before that number. Just make sure. If there is a single element, then you don't have to put any bracket. You can just write the number in the subscript. But if there is a compound which contains more than one element, then you have to put that bracket before putting the number in the subscript. Okay, so your answer is NH4 twice Cr2O7. Okay, next question. Which of the following is not an indicator of a chemical reaction? I have already discussed the characteristics or evidences of a chemical reaction with you. Okay, so what we have learned there, we have seen the change in color, we have seen there the formation of precipitate, we have seen the evolution of gas was there. What was not there? Melting of ice. Okay, because here only the state is changing. And I have already told you, and you all must be knowing also, that whenever only a state is changing, most of the times it's a physical change. So there will be no chemical reaction for this. Okay, clear? Next. Okay, now this is an important reminder for all of you. I have just told you a few minutes before that every gas that is released has its own persona. Okay, so they follow some rules and you can just guess it from them that which gas is released. Okay, so for hydrogen gases, just remember that whenever the bubbles are coming out of a solution in a reaction, then hydrogen gas is present there. Similarly, to know that whether a carbon dioxide is present or not, okay, for that you have to go with your color change. So as you can see this in this reaction, that lime water, okay, lime water turns milky. What is the formula of lime water? Lime water is your slaked lime, that is your CaOH twice. This is your lime water. So inside this, if you add carbon dioxide gas, we will get calcium carbonate plus water, and this is your milky solution. Okay, so as you can see that this lime water without carbon dioxide is colorless, but with carbon dioxide it turns milky, and as you can see here. Okay, so to know whether a carbon dioxide gas is present or not, this is one example where you can find carbon dioxide gas with the change in color. Okay, similarly with the evolution of gas, you can identify a hydrogen gas. Okay, next we'll be discussing such important points in between also. Okay, now there is one more balancing chemical equation. Okay, so now let's just balance this. So calcium hydroxide, we have just written the formula before. So this is your lime water, that is your CaOH twice, and this is your carbon dioxide, that is your CO2. Now what you are getting in the product side, you are getting calcium carbonate, CaCO3, and you are getting water. Okay, so now this is the reaction. So first you have to write the reaction in the formula form before balancing it. This is the first step. Okay, for that you have to know the radicals, okay, the valencies of the radicals, and the chemical formula, it's a must for balancing a chemical equation. Okay, now after this what will you do? So you will just see which elements are present on the either sides. So there is calcium. So let's just now try to balance this equation without forming a table. Okay, so as you can see, because we'll be having very less time for balancing a chemical equation or for solving a question in board exams. Okay, so let's just now try to solve it without forming a table. So here calcium has one atom, here also calcium is balanced. Okay, now moving further, going to carbon, carbon is also 1, and here also carbon is 1. Okay, so carbon is also balanced. Now what is remaining? Hydrogen and oxygen. Now going to hydrogen, here hydrogen has 2 atoms. Here also hydrogen has 2 atoms, so it is also balanced. So now only oxygen is there which is not balanced. So here oxygen has 2 atoms, and here oxygen is also having 2 atoms. So total number of atoms of oxygen is 4 on the reactant side. Whereas in product side also there is 3 and there is 1. So if there are atoms present in different compounds, you have to add it. You have to add the total atoms in the reactant side, you have to add the total atoms in the product side. Then you can only observe that whether the reaction is balanced or not. So oxygen is also 4. So likewise you can see that this reaction is already balanced. So to check whether a reaction is balanced or not, in order to check, we don't have to form a table. We can just check by likewise, okay, by putting the number of atoms using arrows and by observing that whether it is same or not. Now moving further, now moving to the next topic. So our next topic is types of chemical reactions. Okay, so now discussing about the types of chemical reactions, these 4 are the main chemical reactions that we'll be discussing. And after that, I have not mentioned redox reactions here, we'll be discussing it also. Okay, but these 4 are the main chemical reactions that is happening around us. Okay, so what are those reactions? Let's just name one by one. They are combination, decomposition, displacement, and your double displacement. Okay, now decomposition, you can classify it into 3 more types. Okay, in the presence of heat, in the presence of light, in the presence of electricity. So in the presence of heat, that is called thermolytic decomposition. I'm just writing the name here. Thermolytic decomposition. Okay, for light it is your photolytic decomposition, and for electricity it's your electrolytic decomposition. Okay, so we'll be discussing one by one. Then comes your displacement. Similarly, in double displacement also there are 2 categories. One is your precipitation reaction and another one is your neutralization reaction. Okay, so all these reactions we will be discussing one by one, then we will be solving questions related to them also. Okay, so now let's just start with combination. Okay, so this is your combination reaction. So what is your combination reaction? Combination reaction is that chemical reaction, the name itself tells what it means. Combining means you will combine 2 or more to form one product. Okay, so here the reactants can be more than one. Okay, but the product only will get only a single product. Then only we can classify that as your combination reaction. So where 2 or more elements or compounds react to form a single product, that is your combination reaction. Now one more thing about this combination reaction, most of the combination reactions are exothermic in nature. Now I have already told you what is an exothermic reaction. Exothermic reaction is any reaction that releases heat. That's your exothermic reaction. Okay, so combination reactions are mostly exothermic. So heat are released in this reaction, because in combination reaction most of the reactions are those reactions which occur on their own. We don't have to increase any heat, temperature, pressure in order to perform that reaction. Now let's just understand this reaction with example. So this is one example. Okay, these you all must have seen around you also. Okay, especially in industries, in manufacturing industries. Okay, so this is your quicklime, which is called chuna in Hindi. You all must have seen that chuna. Okay, that is used for making homes. Okay, now this quicklime, when you put that into water, you all must have observed that a fizzing sound comes. Okay, and along with that fizzing sound, we can see some vapor coming out. Okay, so what was that vapor? That vapor was your heat that is released in this reaction. Okay, so likewise this is an exothermic reaction, and what is formed? Lime water is formed. that is your slag line. That is your calcium hydroxide. Okay. Okay, so this can be the best example of combination. Okay, because in this reaction we can understand two things. Okay, we are just understanding what combination looks like. Also, we are understanding how combination reactions are exothermic. Okay, so both these things are covered in this reaction. Okay, and this is very important reaction for your board exams also, because what I have observed that some reactions are very important for your 10 board exams. Okay, one of them is this. Okay, any question regarding MCQ or assertion reason or case based, okay, comes from these reaction. Okay. Now coming to your decomposition reaction. So what is your decomposition reaction? So decomposition reaction is that chemical reaction in which it's just the opposite of combination. So what was combination? We are combining two or more reactants to form a single product. Okay, whereas in decomposition we'll use a single reactant and we can break down into different products. Okay, so you can see here that it's a single reactant. Decomposition means breaking down. So it's a single reactant that is breaking down into two products here. The product can be more than two also. It can be more than two. But the reactant will be one only. Okay, remember that. Okay, now it is the opposite of combination reaction. As I have already told you, it is just the opposite of combination reaction. Now let's just discuss the three types of decomposition reaction one by one. Thermolytic, photolytic, and electrolytic. So in thermolytic, you can just give the example of your calcium carbonate. Calcium carbonate breaks down to form calcium hydroxide and carbon dioxide. Calcium hydroxide. Okay, so now this heat is released in this reaction. Okay, so it is done in the presence of heat only. Okay, now in photolytic reaction, you can just give the example of your silver chloride reaction. Silver chloride in the presence of sunlight breaks down. Here you can write CaO. Okay, you can just use. You can write CaO. That will be much more correct. Okay. Now let me just do it like that. Just a second. So we can just write, yeah, just a second. We can just write, what we can write here? We can write CaO plus CO2. Now that will be correct. Okay. So this is your thermolytic decomposition. Now here silver chloride in the presence of sunlight breaks down into silver and your chlorine molecule. In order to balance it, let's just now balance it. So this is a balanced reaction. Just a second. Just give me a second. Yeah, so I hope you have understood this reaction. Okay, so now let me just, yeah, so now let me just continue. Okay, so now, yeah. Okay, so now as you can see here, that the electrolytic reaction, in the electrolytic reaction, what happens? So in the electrolytic reaction, these are those reactions that happen in the presence of electricity. So in these reactions, these reactions will occur in the presence of electricity. So what will be the common example? So the most common example will be water. So if you break down water, it gives you hydrogen plus oxygen molecule. Now just balance this. So it will be like this. So this is your electrolytic decomposition reaction. Okay. So likewise, we have seen all the reactions in this. Okay. Now let us just continue with it. Okay. So now I hope these three reactions are clear to all of you. Okay. So now this was your decomposition reaction, that is comprised into three types, that is your thermolytic, photolytic and electrolytic decomposition. Okay. Now next, here let me just also give an example of decomposition reaction. Okay. So what is your decomposition? So I am just giving you an example of decomposition, that here we have already discussed this reaction, that here the calcium carbonate, when you heat calcium carbonate, this is your thermolytic decomposition. Thermolytic decomposition. Okay. So now here when you heat calcium, when calcium carbonate breaks down, because there is a lot of heat present in the calcium carbonate, so it breaks down, and it breaks down into calcium oxide and your carbon dioxide. Okay, so carbon dioxide is released here. Okay. Now one more reaction for you in decomposition only. Okay. So what was it like? It was like ammonium dichromate. Ammonium dichromate. What is ammonium dichromate? We have already seen in one MCQ. Okay, so the formula of ammonium dichromate I already have told you. It was NH4 twice Cr2O7. So ammonium dichromate breaks down into chromium oxide, nitrogen and water. Okay, so it breaks down into chromium oxide, nitrogen and water. Okay. Now this कैसे हुआ है?